Okay, welcome to another conversation. I'm really excited to have Jim Dowling with us. Jim is the founder and CEO of Hopsworks. Welcome to the this conversation, Jim.
Thanks, Joe. It's great to meet you again.
Absolutely. So tell us more about Hopsworks, your background.
Yeah, HubSpot is a platform for developing and operating AI applications at scale. It's primarily known as one of the first what we call feature stores, a data platform for AI systems. So for storing data for training and for particularly building real-time AI systems. So if you think about the technology that powers TikTok, TikTok has this kind of very interactive feel when you click and you swipe, it adapts to your behavior. That's the kind of platform we build to support those type of applications. A little bit of my background. I came into the startup world a bit later in life. I worked at the university for many years. I also worked at MySQL, and the company is kind of a blend of MySQL. We forked a database from MySQL. That's the core technology, and then we built out a platform on top of that database. That database is now called RonDB, open source, and Hopstix is kind of this scalable data AI platform. And I guess for your viewers, it's probably think of it as being Databricks but real time. So we actually got the analytics part as well, more
That's
real
really
time.
cool. Yeah.
Yeah.
And did Hopsworks grew out of your research?
Well, it originally, I mean, everything starts. I'm a systems researcher originally, so I work both in AI and in distributed systems, and we started building this scalable data platform on top of this database for DB, and this is maybe at this stage it's 10 years ago we started, and we said, okay, well, what will we do with a scalable data platform that has both like low latency data and then scalable data storage? And we won some prizes for our file system, HopsFS. And we thought, okay, AI is kind of a really exciting area. So we built in specific support for how to manage multiple tenants on a single shared cluster. And then we started adding compute and support for GPUs, and it just kind of snowballed from there. So then it became the kind of a scalable data platform for AI is how we actually raised venture capital funding. We're a venture capital funded startup. And then from there, we then got our first customers, and that's kind of how it grew slowly. But enterprise software is a very, because we're an enterprise software product, we're not selling directly to consumers so much, or we haven't been so far. We'll get into that maybe a little bit later with a SaaS platform, but been selling primarily to large organizations. So very large companies, Fortune 500 companies, but also across a many wide range of horizontal, or sorry, of verticals. So we have everything from like law enforcement, defense to banking, insurance, healthcare. It's a wide variety of, and of course, entertainment and e-commerce.
Yeah, I'm curious, Jim, if you can talk more about the problem that Hopswork is trying to solve. You hear a lot of people talking about data infrastructure, data platform, now AI infrastructure, but always feel like Hopsworks really understand the piping
Yeah.
to really enable organizations to actually get on and do more complex things like model building, etc. And so, given your background in distributed systems and AI and serving these large customers, what are the core problems that HopsWorks is focused on solving? If even if there is a spectrum, because I know every customer is different.
Yeah, I think the hardest problem most customers have is that they sit on a lot of data and they realize that we can generate value with AI using our data. But then the problem is, how do we get our data to the models? Either if we're training them, but many people are not training them now. They're using off-the-shelf, frontier LLMs. But you still, if even if you have a frontier LLM, you wanted to use your private data to build a service or whether it's internal or external facing service that generates value. So your data will now be called context. That's the kind of
Right.
term we use for data that helps LLMs make better decisions and execute tasks better. But how do you get that data to the models? That's the hard challenge, really, ultimately. And a lot of that data will be in databases. It's not just in files. And it's not always going to be in what we call vector indexes or vector databases, which was kind of the early work that we did on LLMs for RAG. For us, primarily, we say, okay, if our data is in databases, how do we centralize it so that you can make it available for AI? And then how do you, in a governed, secure way, make that data available to be used for making predictions with AI, what we call inference, but also for training AI models. And that's kind of the value that we add. And I think, I've taught on a course, briefly lectured on your course, Joyce, and I've been teaching a course at KTH. And what we do there that's a little bit different, and also the book I just finished for O'Reilly is how do I structure an AI system? And I think that
Yeah.
architectural question is something that a lot of people get stuck on because they might build their first AI system, might be a dashboard that maybe predicts something that runs at a certain cadence every day it's updated. In the book, I cover air quality predictions as a dashboard. It's a nice system. But then you move on, you say, well, I'd like to build an interactive system. Maybe it's going to be something like in the book, I cover credit card fraud. It's a real time. I want to make a decision in 20 milliseconds about whether this credit card transaction is potentially fraudulent or not. And then you move beyond that and say, well, I'd like to build an agentic system. And typically people start over from scratch and they go, well, there's no commonality between these systems, whereas in fact there is. And I think that's what the main message in the book is that all of these AI systems, batch, real-time, and agentic, can follow the same general structure. We have pipelines that manage their data. We'll call them feature, context, or vector embedding pipelines. They take the raw data and transform it into the format that you need for your model for training or inference. You have the training pipelines, which are still used, but maybe not as widely deployed in the agentic era. And then, of course, we have then the inference or agentic pipelines, the pipelines that actually make the predictions. They take the data, use the trained model, and they make the predictions for the client. So those three classes of pipelines, these feature pipelines, training pipelines, and inference pipelines,